Hi, my name is Yasser and I will be presenting here Plumber, a demo about a modular framework to create information extraction pipelines. Let's dive into the details of the framework, how it works, what is the methodology behind it, and then we will check out an interactive demo of it. So first things first, what about triple extraction and alignment? So the framework basically relies on these concepts, and to clear them up a bit first, so a triple extraction relies on that we have a piece of text or a piece of natural language text, and then we need to convert it into structured data, which means that we have it in a form of triple, and this triple, as in this example, Rembrandt painted the storm on the Sea of Galilee, technically means that we have a subject, which is Rembrandt, the painter, the action that was taken or the predicate is painted, and then the storm on the Sea of Galilee is the object. We then align this triple to a knowledge graph, and in this case we took DBpedia for example, and we can see here, for example, Rembrandt was the DBpedia resource, while painted the predicate is now DBO artist, which means it's the ontology from DBpedia, and also the storm of the Sea of Galilee is still a resource. That's the main concept that the frameworks build on top of. How the framework is actually created and designed. So the Plumber is modular design framework that has separate modules that interact with each other. Let's start from the bottom of the framework, which is the IE component pool. Here we can see we have different types of components that perform different subtasks of the information extraction overall task. Using these components, certain pipelines are generated using a pipeline generator, and we see here in the IE pipeline pool, we see samples of different pipelines that can be actually created from the underlying components. Each pipeline performs differently, and this is where Plumber actually works on top of this and tries to find and compose the best suit or the most suitable pipeline for the job. How this is happening under the hood, the framework utilizes a Roberta-based pipeline selector, which is a transformer-based model that tries to classify a given input, which is natural language text, with certain requirements, like for example, what is the knowledge graph that this pipeline should work on, and tries to find what is the most suitable pipeline in the pipeline pool and runs it on it. Kind of a more in-depth look at this, so one might think why different pipelines might perform differently. Well, here is a real example. So if we have the piece of text, which is Rembrandt painted the storm on the Sea of Galilee, it was painted in 1633. The first pipeline we have here has three components. The co-reference resolution component is the first here, and you see it was disambiguated by this component to the storm, which technically it's not completely accurate. So the accurate result here for it, or for the accurate disambiguation for it, is actually it should be the storm on the Sea of Galilee. So this whole snippet of text. Then the triple extractor component, which is here OpenIE, extracts a triple, says Rembrandt painted storm, and then Earl, the linker here, tries to link these parts. So even if the linker did a perfect job, technically the components before it, they didn't really perform that well. That's why, I mean, the overall result from this will not be satisfactory. As we see, for example, in pipeline 2, different components produces different results. So this neural co-ref here actually was able to disambiguate it correctly. But here, for example, and also clause IE was able to produce a correct triple, but the linker here, DBpedia Spotlight, failed. While the pipeline pipeline 3 here actually is the one who produced the correct set of results. So here you can actually see why different combination of components in different ways produces different results. And Plumber tries to leverage this information to find a suitable pipeline given an input text. Let's check the demo. Plumber is integrated within the ORKG, the Open Research Knowledge Graph infrastructure. It's under Tools, Pipelines. This is the main interface of Plumber. As we see, Plumber consists of 3 stages. So we first need to specify a text, and then we select the pipeline and wait for the output. We can upload a text file here, but for the demo purposes, we will just stick to some sentence we copy here. Barack Obama is the 44th president of the USA. He was born in Hawaii. You see, once we actually pasted the piece of text here, step 2 is activated, and then we can start using it. In this select pipeline, we can actually select one of predefined pipelines. This is maybe for the ease of use, but what we want right now is to actually maybe create the pipeline ourselves. So let's maybe use clause IE for an extractor. For now, let's not really care about the resolver, and then maybe choose Falcon as a linker. For each of those components, you see we can actually hover over it and get more information about it. These are community created components, so this information is actually fetched from either the publication or the website that actually offers these tools. And these tools don't really have to be created specifically for the task of information extraction or the extraction of structured triples out of text. Rather, they are sub-tasks in the IE information extraction kind of overarching task, and they can be used in different NLP domains in general. So we can actually run the pipeline. We might need to wait a bit, so each pipeline is different in terms of the number of components that it needs to compose, it needs to call, and each different component actually might have their own performance issues. Actually, we see that output is now activated, and we see the output of this pipeline. So from an overview, we see the extracted triples is the result, which is also what we care about. So as we explained in the start of the video, we care about the aligned triples or the structured triples. And these triples are in the form of subject, predicate, and object. So here we have Barack Obama is the 44th president of the USA, also is the president. He was born in Hawaii. So actually this dependent on multiple things. So we see these links. These were linked by a linker, which is here in this case Falcon. So if we change the linker, we get different results. Also, if we change the extractor, we also get different triples. So why not, let's maybe go with OpenIE this time and run the pipeline again. As said, so running the pipeline, we need to wait a bit. And we will most likely get different set of triples because each triple extractor creates a different set. And you can select multiple triples. You can, multiple extractors, multiple resolvers, and multiple linkers as well. We see here that actually the output is now different because the pipeline ran its course, and now we have a different set of triples. If certain triples are not really accurate or correct, you can report it. We get the feedback. Currently, we only store the feedback. We don't really have an active learning loop in the system, but we are hoping to extend this in the near future. However, let's maybe take a look here at triples 5 and 6. So we see here the pronoun he was not really resolved. We are hoping that if we activate certain resolvers, they will be able to actually resolve this to, which should be here, Barack Obama, and link it as well. So in order to do that, let's maybe check now the functionality of Plumber itself. So here we have this button that says Compose Suitable Pipeline. When we run it, it says composing, and now Plumber under the hood is trying to find out what is the most suitable pipeline. And actually, it changed things for us. So it told us that we should use the extractor OpenIE, we should use the resolver neural coref, and use this linker, which is Falcon 2.0 that runs on Wikidata. Let's run the pipeline and wait and see the results. We see actually now it's a different set of results, but the nice thing we can actually directly observe that triples 5 and 6, they are now different. So they were beforehand, they were he, and now they're actually linked to Barack Obama. And as you see here, this Q76 is actually the Wikidata corresponding entity for Barack Obama. We can actually go and see it and hopefully see if it's correct. And we see here actually Barack Obama is Q76, and that's from Wikidata. That's also correct. Also for some predicates, so is president is also linked, was born in is also linked, USA, Hawaii, 44th president, all of them are actually linked. So the thing is, so some links may be inaccurate. Let's check 44th president. It doesn't really have to be correct. So you see here, it actually links to the 44th Division, which is an Imperial Japanese Army infantry unit. So that's also part of the downside of using community components. So that means that Falcon 2.0 failed to link this correctly. But still, for other cases, maybe like the USA, it was able to link it correctly. Okay, so maybe for another use case, we can also use Plumber on other kind of text. This is some text from a publication, a scientific publication about COVID, and this is the abstract of that publication. That means we need to link it to maybe a different knowledge graph. So we can also here create or use maybe this predefined configuration here, which is the R0 extractor. The R0 extractor should maybe try to use it. But why not try to do compose suitable pipeline and let Plumber figure out maybe if there is a different or more suitable pipeline. And we see here that this ORKG-ANN linker was activated as well. This is a linker for the Open Research Knowledge Graph infrastructure. Now we can actually maybe run the pipeline and we actually get different results. So we see here something called contribution 1 as the subject, and then it has different set of predicates. Some are linked, some are not. We see, for example, there's something called maybe the 95 confidence interval. If we check it, it's actually, this is a property view, and we see it extracted certain set of results. Like, for example, here the mean incubation period is 7.1. The incubation period itself, this seems to be a range, so this extracted this range itself. Let's try to do something different. Let's look up for this 7.1 and let's make it 7.9 and run the pipeline again. We see here the object was changed to 7.9. There's the option to, you can actually download the CSV of the triples in case if you want to import them or using differently. But yeah, that's basically the general direction of how Plumber works and what are the use cases that we can use it. For future vision, we are hoping to support multiple input formats. So for now, it's just text. We hope to support PDF and other input forms. And for the components, of course, we would like to support even more and more components from the community, or even give the ability to provide your own component as a third party and link it as well. And basically, this is it. For more details, feel free to go to the GitHub repository. The code for Plumber is open source. You can use it, you can adapt it, you can extend it as well. Thanks for attending this.